Um, okay, so let's do this question. How about this one? I think this one is easy too. You have 680 people in a group. Um, the question is, do there exist two people who have the same first and last initial? Okay, so we are looking for two people जिनका first name और last name same letter से, oh sorry, जिनका first name भी same
Yeah,
letter से start होता है और last name भी
or
same
last
letter
name.
से start होता है. Okay,
So
yeah. So for
boxes
the
are
first,
combinations.
yeah,
27 into 27.
26 into
26, sorry,
27.
26 letter.
Yeah, yeah.
It is equal to
6, 76.
yes, sir.
And this is the number of pigeons, 680. So 680 is since more than 676. We
Yes,
know
there
that there
must be.
must be two people who have the same first initial and last initial.
So like Abdul Muqaddim and Asman.
सर
Yeah.
सर लेकिन ये फर्स्ट इनिशियल के लिए 26 इंटू 26 केसेस होंगे और सेकंड इनिशियल के लिए भी 26 इंटू 26 केसेस नहीं होंगे.
No. So here's the thing. So what I'm doing is I'm again जैसे हम यहाँ पे पहले कर रहे थे, I'm considering all possible name initials. Okay, first and last. So for example, someone could have AA as initials of their names, first and last. Okay, someone could have AB and so on. Okay, mine is MS. Okay, so these are all possible combinations of initials that one could have. Okay, for the first name there are 26 options. For the last name there are 26 options. Okay, so the size of this set would be 26 into 26. The number of possible initials of names is 26 into 26. Okay, so if I have a group of people which exceeds this number, तो उसमें दो लोग ऐसे जरूर होंगे जिनके जो initials हैं वो same होंगे. Okay,
Okay, sir, thank you.
so I'm not starting with two people. I'm starting with the initials. I'm counting the total number of possible combinations of initials there can be. Okay, once I have that, now I apply the pigeonhole principle by defining pigeons and pigeonholes, and I show that since pigeon is the number of pigeons are more than the boxes, there must be two people which have same initials. Okay, let me see if there is some more interesting question. So of course, I don't know if you guys realize, you can generalize this a little bit more. Okay, if you have a lot of people, if pigeons are a lot more, you can actually quantify the maximum number of pigeons that there can be in a box. Okay, you can actually give me more pound. अभी तक तो हम सिर्फ ये कह रहे थे कि एक से ज़्यादा होंगे. Okay, हम कभी कभी हम अगर पिजन्स बहुत ज़्यादा हैं तो हम इससे कुछ और ज़्यादा भी कह सकते हैं. Okay, so for example, if the number of pigeons is 7 and the number of boxes is 2, then we know that there is a box which contains 3. Oh no, what is that? Oh no. So here's the thing. This is stated in a different wording. Let me read it. Consider a function whose domain has n elements, whose target has k elements for n. Actually, it's fine. इसकी जो figure है वो शायद गलत बनी हुई है. Okay, forget about the figure. Okay, so you have n pigeons and you have k boxes. Okay, there must exist some box which contains ceiling of n over k pigeons. Okay. That's the generalized pigeonhole principle. If you have n pigeons and you have k boxes, then then there must exist some box which contains the ceiling of n over k pigeons. Okay, so originally हमारे पास ये था कि वही हमने ये कहा था कि you have n and then you have k which is less than n. Okay, तो फिर हमने ये कहा था कि there must exist a box which contains more than one pigeons. Okay, and that it follows from here because you have n divided by k, where k is something less than n. This is definitely more than one. Okay, this is at least 2. Okay, so this reduces to the original pigeon if you replace k with the generic number. Okay, all right. So
यहाँ 4 में आ गया 3 की बजाय सीलिंग ले रहे हैं ना
yes.
तो 3.5 आ जाएगा तो उसकी सीलिंग 4 होती है
That is actually true. You should get a 4 here. Again, my apologies. It should be 4. Yeah. Okay, but this is the general principle that if you have n pigeons and you have k boxes, then you must have a box which contains at least n over k seal pigeons. Let's see if there's an interesting example. Alice bought 15 cups of coffee in a week. Then there was a day in the week in which she bought at least 3 cups of coffee.
Yes, sir. 7 days in a week, 15 over 7 cap.
So you have 15 cups and they were bought over a period of 7 days. Okay, which means that you have 7 boxes. And you need to place 15 cups there. Okay, there must exist a box which contains 3 cups because 15 over 7 seal is at least 3. Yeah. Okay. All right. So this is the same example, something very simple as well. Let me think about something interesting. I had an interesting example in mind. Okay, I think it. So I might be wrong. I think मेरे ख्याल में आपने आपकी book में ही मैंने कहीं देखी थी. So the statement is that for every n, for every integer n, there exists a number, integer again, of only 0 and 1 digits, such that so let's call this integer x, such that n divides x. Okay, I think this is the statement. You should look up the book if you find there is some problem with this thing. Okay, so the statement ये कह रही है कि pick any integer n. Okay, which be weird सा ले लो, I don't know, 2, 8, 9, 3, 5. Okay, so there exists an integer which only contains ones and zeros, such that ये जो weird integer आपने लिया था ये इसको divide करेगा. Okay, try proving it using pigeonhole principle. And of course the other problems in your book as well. मैंने इसको carefully आपकी book को नहीं देखा तो I don't have special problems to mention today. I'll do that in the next class. Meanwhile, you can look them up yourself. Pigeonhole principle is very important part of the counting chapter. Okay, तो इसको देख लीजिएगा. Any questions, people? So that's it. That's it for today.
Sir, yes, sir.
Yeah.
9. Yes, sir. 900.
Any
सर
questions?
वो
for-
कैलाश
yeah.
वाली प्रॉब्लम पे एक दफा देखिएगा
Can you repeat?
सर वो जो कलर्स वाली प्रॉब्लम थी उस पे एक दफा कीजिएगा
Okay,
स्लाइड।
sure.
Okay.
So this was the problem. Okay, so you have a grid of 4 by 82, where each point is colored either red or blue or green. Okay, and the statement says that there exist at least 2 rows where colors are exactly the same. Okay, that's the
सर
statement. Yeah.
क्या सर इसमें हमें मतलब ये प्रूफ मतलब ये फाइंड करना है कि कितनी वो रोज होंगी जिसमें ये पॉसिबिलिटी होगी, या ये प्रूफ करना है कि कम होंगी भी, या इसके बगैर भी कोई कॉन्फ़िगरेशन हो सकती है या नहीं?
यस, हमने यही शो करना है कि इसके बगैर कोई कॉन्फ़िगरेशन नहीं हो सकती।
सर लेकिन ऐसा नहीं हो सकता कि पहली लाइन पूरी रेड हो, अगली पूरी ग्रीन, फिर ब्लू, इस तरह से कंसेक्टिव सारे चलते जाएं और उसमें तो भी दो सेम नहीं आ सकेंगे।
सो देखो, स्टेटमेंट अगेन ये नहीं है कि दो कंसेक्टिव रोज सेम होंगी, सिर्फ दो रोज सेम होंगी। वो हो सकता है कि पहली और आई डोंट नो 70th रोज सेम कलर की हो। ओके, तो
ऑलराइट सर, मुझे
कंसेक्टिव होना
क्वेश्चन की अब
जरूरी
समझ
नहीं।
लगी है अभी।
हाँ नहीं, कंसेक्टिव नहीं, कुछ मतलब कोई भी दो रोज। Okay, so if the number of rows is 81, then there actually exists a configuration जिसमें कोई दो सेम नहीं होंगी। But if you add one more row, 82, then you can't make a configuration which does not contain two rows with the same color by the pigeonhole principle.
सर रो के सेम कलर होने का मतलब ये है कि मतलब पूरी की पूरी, मतलब पहला जो डॉट है उसके दूसरे वाली रो के पहले डॉट से मिले, सेकंड वाला डॉट उसके कलर से मिले, इस तरह से करके।
Yes, exactly. Yeah.
राइट सर।
Respective columns should have the same color.
ऑलराइट सर, अब प्रॉब्लम की मुझे समझ लगी। थैंक यू सर।
Sure. Okay, anyone else?
Sir, could you explain the last question, that is 0 and 1 digit?
Sure. So the problem says that pick any number you want. There exists another number which only contains digits 0 and 1. Your magic number will divide this number. Okay, so any number divides some number which contains ones and zeros. Okay? So you need to prove the existence of this number by pigeonhole principle. You need to show that whatever crazy, weird looking number you start with that looks like it does not divide anything that only contains ones and zeros, you would fail. It will divide some number which only contains ones and zeros.
Okay, sir.
Sure.
सर मतलब पूरा पूरा डिवाइड होना चाहिए, मतलब कि
हाँ, पूरा
मतलब
डिवाइड
डिवीजन
होना चाहिए।
एक जगह पे जाके स्टॉप हो जानी चाहिए।
डिवीजन का मतलब ये है कि आई डोंट नो, प्रॉपर उसको डिवाइड करेगा बाय इंटीजर। आई डोंट नो, यू वुड हैव अ क्वोशिएंट एंड रिमाइंडर 0।
मतलब पॉइंट में आंसर नहीं आ सकता, राइट
यस,
सर?
पॉइंट में आंसर आ सकता होता तो दिस वुड बी अ
मतलब पॉइंट
मीनिंगलेस
में आंसर
क्वेश्चन,
नहीं आ
राइट?
सकता।
So would divide it properly. Anything else, people? Okay, we'll do more of counting on Thursday. आपके जो एग्जाम 2 थे वो मेरे ख्याल में अभी हमने उसको हाथ नहीं लगाया है ना उबैद? We haven't touched it. We haven't graded it, है ना? We have
Yes, sir.
been we have been busy with our own problems. Speaking of which, Ubaid got his paper accepted at the top computer science conference, which is Sky 2021. So you should congratulate him whenever you meet him or whatever. Okay, this is a big thing because I know my colleagues in LAMS who have been trying to get a paper in Kai for I don't know multiple years and failed. Okay, so this was a sort of a great thing for our lab. So Pat is one of the authors there. All right, thank you guys. I'll see you on Thursday then.